Good morning. I hope you are able to hear my voice and also able to see the screen. At least one yes from the 16 participants who have joined already.
Yes, sir.
Okay, let others can join in few seconds. Yeah, I'm sorry. Professor Kagla sir and Professor Sushila madam used to take class for last 2 weeks, and hope you are enjoying the classes by our Professor B. A. Kagli. He's a well-known expert. Okay. Few classes back, actually, we discussed about the fluid mechanics, that is particularly the properties. I am much stressing on some basics mainly because this is a new field where you are not aware of some of the terminologies, but at the same time, it is also complex. Means, as such, if you see the movement of the fluids, you can't define them, their movement in terms of the physics. Means, or you can't have the raws, can't have the mathematical tools in the sense mathematical expressions where the flow can go. For example, if I want to collect a water, about 100 liter of an water, if the pipe diameter is about half centimeter, then what up and if the flow rate is so no flow rate, how long I can continue? For example, assume that if a tanker comes to your village for supply of the drinking water, assume that there is only one outlet about some 2 inch or about 5 inch, it doesn't matter, even 3 to 5 inch. Okay, how long it will take to empty that entire tank? Maybe half an hour, maybe 1 hour. Of course, you can calculate. There is no issue actually. Okay, such type of things is an issue. But at the same time, if you want to pump water from an under tank to the over a tank. Okay, for example, how long I can run the pump? How can run the motor actually to uplift the water to such extent? There are things, but at the same time, instead of that, for example, if they want to release the water from a check dam or maybe a reservoir, okay, assume that you are well aware of the release of the Kaveri water to the Tamil Nadu as an treaty because the rivers belongs to the entire nation, not be restricted to the state of that kind. Of course, there should be mutual cooperation and cordial relationship among the states also. Okay, always the water has to flow from high potential energy to the low potential energy. Means it has to move from higher potential energy to the ocean always, or maybe sea they can call. If they want to release about 100 TMC of water, 10 TMC of water, 2 TMC of water, about 10 to 12 TMC they are telling actually, 1,000 million cubic meter. How much that water? Who has to measure that one actually? If you are releasing that, is it not about 1 liter, 10 liter, or 10 tanker or 100 tankers of that kind? Measurable quantity. If you are allowing the water to flow through a canal, through the check dams, suppose if you release the water, whatever you are released at the starting point, maybe the Kaveri Basin, for example, and the Mettur Dam or something like that they will call in Tamil Nadu. That is a check dam they want actually. The process is that may take water more to around 100 and 200 kilometer from here to there. The water should not be lost in the process of the journey while going through a canal. It is not the water was not sent through the pipes actually. Water was not sent through the pipes. Okay, in the sense. How long means what must be the process? Evaporation might have occurred. Some losses like an sedimentation has occurred and the water might have entered into the earth actually. Okay, it is not a concrete check dam in such a way that it can't not check dam, concrete canal in such a way that always whatever you are releasing the water, the same water will go there. Okay, or even sometimes the farmers or maybe an agricultural persons might have pumped in some water from the canal to their land for the cropping actually. It's not a bad idea, but if there is a source, certainly people will make use of the source to a greater extent. Okay, if that is the case, how they can do that actually? That is a challenging issue. We will see that how they will do that. Still, that's why we need still some more understandings, particularly in terms of the terminologies and other things. Then only we'll proceed for the rest of the part. Okay, let us see that how they can do that. See again the basics. Don't worry about the rest of the part. Rest of them is about eight topics are there, starting from Newtonian fluids to viscous fluids. They are the preliminary. Some 2 3 derivations are there, like equation of continuity, that is the conservation of mass, flow of viscous fluids, that is how that will flow, and one derivation from the Navier-Stokes equation, how that the fluid can flow through a pipe, cylindrical pipe actually, and solution for that one, and Bois-Delay equation. These are the 3 derivations, standard derivations you can expect, and how that ideal flow and rotational flow will influence the fluid mechanics. Okay, then the fundamentals of non-Newtonian fluids, that it can be covered, not an issue actually. Okay, because if you are well aware of these terminologies and the concepts of the fluid actually, then it becomes easier to ask also for me to go through in a relatively good manner rather than keeping very slow at the moment whatever I am doing right now from last 4 or 5 classes of that kind. Good. Here, there's one condition will come actually. I take it from me. It is granted for you in such a way that whatever the examples I'm giving, those examples are well aware of you. If the concept is exciting you, then I'm thankful to the nature in such a way that the main purpose of the scientist, the main purpose of an academician, the main purpose of the science particularly while learning in at the school level or at college level or at university level is to understand the phenomena, understand the processes which are happening in the nature, why they are occurring, how they are occurring, at what time they are occurring, or what must be the reason behind it. Actually, we want to know the reason. Those reasons can be utilized for the mankind for the better off. For the better off, we'll think that there is one condition in fluid mechanics they can call, that is the no slip condition. You should not slip. Okay, while walking on a road when it is a mud, okay, when it is a slippery, they can call actually. Sometimes you might have balance, you might have slipped actually, even though you're having a practice of walking more than 21 years, almost right now you are in the fourth semester, around 22 to 23 years, not less than 22 years. Okay, maybe excluding 1 or 2 years when you are kid actually at the time of born. But about 20 years of experience in walking, still you will slip at some places. Okay, most of the people at the older age will slip and they could not able to balance their body. Slippery is different. There is no slip condition. Of course, if you are not slipping, in a sense, it's called the no slipping conditions. When we are walking on the road, we will not slip. When we are walking on grassy, of course, if it is with some watery and other things, there may be a chance. If we are walking on some slab, for example, rocky slab, which is with the algae or something like that formation, there may be kind of a slippery. Or even on houses, actually, if there are a spell of water, particularly on granite slabs, there may be possibility of the slippery. If you put a slope water, certainly it has to go for slippery. Even if you spill off some oil drops, actually, certainly it go for the slippery. Okay. Here there is a condition called the no slip condition. Okay. Of course, nothing should fall when you are walking. We are walking on earth mainly because the gravity is there. Otherwise, it is difficult. If no gravity at all, we will fly like birds actually. If there is no gravity at all, nothing will pull down us. Okay. Even though we are having a mass or weight, they can call inanimate mass, weight of about now think I'm trying to tell you the two words, weight and mass. Okay, weight of a person is 50 kg, mass of a person should be 10 times less than, not 10 times less. If a weight of a person is 50 kilo, okay, average weight of a person in 4th semester MSc 50 kilo, what should be the mass? W is equal to m times g. If W is 50, m should be W by g. G should be 10 roughly. 50 by 10. The mass of that object or mass of a person should be hardly about 50 by 10 is 5 kilo, 5 kilogram. Now think of, now think of the fluid. What we are saying is that fluid flow is often confined by solid surfaces, of course. Okay, if there are no solid surfaces, if you allow the fluid will not flow at all. Okay, and it is important to understand how the presence of a solid surface affects the fluid flow. For example, let us take the different kind of a slabs, like a slab made up of some container like a plastic container. Okay, something like an tar road, something like that mud wall, mud. Okay, the sand of that kind, something like that a grassery. Okay, something like that only in the very smooth surfaces like a glass, maybe a concrete of that kind. If you allow the water to flow, it will flow in a different way. Certainly we are aware of it actually, and the surface has to affect. Okay, if the surface is very smooth, the fluid will flow freely. If the surface is having a roughness, the fluid may not flow freely as to the extent that at which the free surface exists. Or maybe for example, like take a tar road, maybe a cemented road, maybe in something like a road. If you are riding a bicycle, okay, bicycle will move freely even with small forces. Okay, if the friction offered by the road is less, if the friction offered by the road is very, if the road is not so free, in the sense is not so friction actually, it can move very freely. But at the same time, imagine if a vehicle moves with certain speed, to bring the vehicle down, to the rest or to reduce the speed, friction is essential criteria. Without friction, you can't bring the vehicle down to the slower speeds. Understand how the presence of the fluid solid surface affects the fluidity. For example, if you are allowing the water to pass through a pipe, for example, for gardening, you may be holding some pipe for gardening, for flowering and other things. Actually, the fluid has to flow through the different kind of a pipes. You might have seen that the inner surfaces should be smooth to a greater extent, apart from the curvatures it was drawing. Actually, okay, some of them you can say that maybe a tough task like in piping, like in PVC pipes or iron pipes or stainless steel pipes or something like that. It is not material dependent, it depends on the smoothness or the surface nature, solid surface nature they can call. Actually, we know that, don't call it as an WKB approximation of that kind. We know that water in a river cannot flow through large rocks and must go around them. That is the shown in the diagram on right side. Actually, maybe a river, maybe a lake, or maybe any pond, or maybe anything. If you allow the water to flow from higher potential energy to the lower potential energy may be getting a confusion. Let us think in such a way that it has to move from highest point to the lower point. Always water has to flow at the lower points, means because of the differential gravity, potential gravity they can call. Why river has to flow towards the ocean? Why oceanic river, sorry, not oceanic river, why ocean water does not flow towards the river? Is there any possibility in the universe in such a way that the oceanic water will flow back to the rivers? Not due to the wind and other part, not due to the oceanic waves. Are there any possibilities? Ocean is at lower height, lower level actually from the surface. That is the mean sea level they can call. Always all water bodies have to flow towards the ocean, preferably mainly because of the, to attain the stability, or to reach the lowest potential energy. Water has to move from the higher terrain to the lower terrain of that kind. That is the reason, rocks and must go around them. Here what the question is that water in a river cannot flow through large rocks. Okay, can you expect that? If you are allowing, if you are putting not a pebble, not stone like that, it's a big stone of that kind, that or maybe the size, actually water body will never flow through the rocks. It will take a deviation and moves around the rock. Fine. That is, the water velocity, if you take a normal to the rock surface, must be zero. There is no doubt. How do you define the velocity? That is how that displacement can happen with the time. Actually, there is no displacement of the water if it falls or touches the surface of a rock normal, perpendicular to a greater extent. There is no doubt. And water which is approaching the surface normal comes to a complete stop at the surface of the rock. That may happen even for any kind of an objects also. There is no doubt. But rock we are having, because at least you can have the visibility. If water, if water comes overhead, need not be up actually, they can call actually facing the head actually they can call, certainly the water comes to a momentary rest or the zero velocity, because we are saying maybe the speed may be the zero, but it is approaching the stone, approaching the rock they can call. That is why the direction also depend, we are mentioning should be the velocity. It completely coming to the stop. Okay, what is not obvious is that water approaching the rock at any angle also comes to a complete stop at the rock surface, and thus, see, means need not be perpendicular, even in whichever be the direction which is approaching. For example, if you are seeing the image properly, assume that this is the direction of the water which is coming here and moving, taking a deviation actually here the deviation, you can see the curve nature of the deviation of that kind. Okay, here assume that, here not assume, this is just sure that it is the velocity should be zero. Even at these surfaces where the water touches this rock actually, there also water will come to the rest at a momentarily. Okay, it will stop, it will not move at all, it will stick to the rock or rock surface they can call. And thus, if you take the tangential velocity of water at this surface is also a zero, means except the water which is leaving this point, opposite point of that kind actually, except that direction. This condition is known as no slip condition, means water is not slipping from the rock, water is not slipping through the rock. Okay, water, because it holds actually, it does not allow, of course, except the formation of some slippery natures like an algae, fungi and of that kind, excluding that at least. This is one of the beautiest property of a fluid, any fluid of that kind. Therefore, the no slip condition can also be considered as the flow. Consider the flow of a fluid in a stationary pipe or over a solid surface that is non-porous. Okay, means impermeable to the fluid. For example, if you take a container, keep the fluid within the container, take some kind of a plate that should be permeable, means where fluid should has to flow from one point to the another point. Put that layer in between the liquid layer from if it is in concentration, if you are expecting with in terms of the concentration, it has to move from the higher concentration to the lower concentration depending on the permeability. If you allow the grape water to the water, dip the grape water, sorry, the grapes into the water, grape will swallow. In the sense, water will enter into the grape, even though the such a solid surface, that is so, depending on the permissibility, Okay, even starch, even some kind of a solutions of that kind actually. But if you dip them into the sugar solution instead of water, okay, sometimes instead of, because concentration of sugar may be more than that of the concentration of the grapes, if that is the case, instead of growing, it may be shrinking actually, maybe shrinking. That you have to think it of. Here, impermeable to the fluid. All experimental observations indicate that a fluid in motion comes to completely stop at the surface and assumes a zero velocity related to the surface. This is the case. Means to say that for all solid objects or obstacles they can call actually, a fluid in motion comes to the completely rest or stop at the surface and assumes a zero velocity related to the surface of that object. That is, a fluid in direct contact with a solid sticks to the surface. I hope you got it. Not entire water. Okay. The layer which is having in direct contact. If it is in contact means it is not going, it is not moving, it is adhered. We can't call it as an adherence. It is not like an adherence of something like adherence of paint to the wall, where it will adhere always to a great extent. It is not adherence of some sticky gums to the surface of any of the material. Okay. But still adherence will be there, but not to that extent actually. That is, a fluid in direct contact with solid sticks to the surface and there is no slip. There is no slip is known as no slip condition. That is not a slippery. But if the process continuously goes like that, for example, even if you are slipping at a surface where there is a slippery nature is there, for that slippery nature, if you allow the fluid to pass through, certainly fluid may not stick onto that. Okay, the fluid property responsible for the no slip condition and the development of the boundary layer is known as viscosity. It is a great application. Viscosity or we can define by some means. We will define it actually by define. It is an important property of a fluid. Okay, either for gases or for maybe liquids to a greater extent. But the solids doesn't have any viscosity. Okay, unless until it is brought under the some pressure or temperature conditions of that kind. Let us see how it has to happen. No slip condition is nothing but a fluid can directly be in contact with the solid, which can stick to the surface, and there are that will not slip. This condition is known as the no slip condition. All materials will have a property to stick, have the stickness actually, except the material like a glass. Okay, where of the smooth surface. Instead of glass, even if you polish the material to the extent of this smooth surface of as that of the glass, those materials also acts like a slippery surfaces they can call. Here, what happens? As per the same case actually, as a consequence of the no slip condition is that all velocity profile must have zero value with respect to the surface at point of contact between a fluid and a solid surface. Means to say that if a fluid comes to the rest with zero velocity, wherever a fluid comes to the solid surface in contact with the solid surface, the velocity of the fluid should be the zero. As it moves, as it is away, moves in the sense as it is away from the surface, the velocity will pick up or the speed will pick up with reference to the solid surface. With reference to the solid surface. Therefore, the no slip condition is responsible for the development of the velocity profile. Means to say that on the right side you see that there is a graph there is a schematic representation they can call actually. The bottom layer is the plate which is having some stiffness, and above that layer is the fluid is allowed to pass through. Maybe assume that water is allowed to pass through. Why on a plate? Okay, means can you expect that on over a plate fluid will pass through? It should be a container. Don't get confusion in such a way that only on single plate, if you put a single plate, allow the water to flow, that the water will flow with some extent of that kind. Of course, even for some kind of a tumbler shape also it will flow. Uniform approach of velocity here when it starts. Okay, lines are parallel here, means starting from the bottom line, the layer 1, layer 2, layer 3, layer 4, layer 5. Assume that it is on the presumption. Why not the arrows are only separated by about half a centimeter? Maybe I don't know, maybe the size of the display on your mobile, how, or maybe the display what you are using the devices for listening to the lectures. Okay, it may vary. If you magnify it, actually it may go for 1 centimeter, 2 centimeter. It is not according to the zoom. What I want to say that these arrows are separated by some known distance. This is the only an indication actually. Either you can put 5 arrows, you can put 10 arrows, you can put 20 arrows, or you can put only 2 arrows, one at the bottom, one maybe at the top. Thing is that the layer is in such a way that maybe you can classify into any number of layers depending on its speed. If there is no gradient, if there is no change in the speed, there is no change in the speed of the fluid between the two layers, within that layer, if there is no change in the sense, up to that extent you can take it as an one layer. Okay, assume that a bottom layer is exactly in contact with the surface, has having zero speed. There is no doubt, zero velocity at the surface. As you move, see that length of the arrow goes up, increases along the side of the axis, actually that is x-axis. Okay, then second one arrow is it is relatively more lengthier, speed should be more, third one may be more, fourth one may be more, fifth one may be more. After 4 5 here on the right side, actually more or less remains constant. Actually this entire fluid, either from the top to the about 4 layers, if you take 4 arrows, if you take, the speed remains constant. No need to take the wind speed at the different points. Entire thing acts like one layer of that kind, maybe up to this. Here there is a changeover, there is a changeover, there is a changeover. Sure. Means relative velocities of the fluid layers, how they can affect. The top layers moves with high speed. Maybe those who are well aware of the very good observation is in a canal. Actually, the canal water, you can see that in the canal the top layers are moving very fast. If you are able to swim till to the extent of the bottom, it may not be a height more than height of about 6 feet, 5 to 6 feet, depending on the height of a canal. I'm not exaggerating actually, preferably to a greater extent. Okay, it allows. That is the velocity profile you can expect. The layer which is in contact should have zero speed. Okay, it is adhered to that. Slowly, as you go up, the speed picks up. At the top, it should be the maximum speed. The flow region adjacent to the wall, in which the viscous effects and thus the velocity gradients are significant, is called the boundary layer. Here, this layer is known as the boundary layer. Boundary between these two, boundary means boundary between the solid object and the fluid is known as the boundary layer actually. Another consequence of the no slip condition is the surface drag. What happens? Being a surface, see, even if you allow with some force for the fluid to move from the left side to the right side, actually even if you apply force, it will be dragged. Surface drags the moment of the flow. Means assume that here from third arrow, from third to the second arrow, from the bottom, third arrow moves with some speed, second arrow means that is the second layer they can call, is having a speed lesser than that, mainly because the second layer second layer is pulled by the first layer is pulled by the surface. Means surface makes as a friction. Because of the friction, the layer immediately next to that of the solid surface slows down, may comes to rest also, slows down. Maybe that slow down may come to the zero velocity. Then layer next to that first layer will also be dragged by the first layer. Third layer will be dragged by the second layer. First, second, third is not the number actually. Subsequent layers are dragged. Bottommost layers are dragging the layers above that, and reduces the speed or velocity of the fluid actually surface. And skin friction drag they can call, which is the force a fluid exerts on surface in the flow direction. Okay, means a no slip condition is the surface drag. There is no doubt, or we can also call it as the skin friction drag, which is the force a fluid exerts on a surface in the flow direction. This is the force which is acting on this surface actually. Because of this continuous force on the solid surface, the surface smoothness of a solid material may change due to the movement. You might have seen the formation of very nice pebbles, very nice rocks, very with different shapes, sometimes elliptical, sometimes circular, sometimes very of different kind actually, very smoothness actually. That is mainly because of the continuous flow of water or water they can call on the surfaces with certain force might have made them into a good shape. Good shape means enjoyable shape of that kind. This is the case when a fluid is forced to flow over a curved surface, such as the backside of a cylinder, for example. Okay, what happens? Backside of a cylinder in the sense, backside of a cylinder in the sense, being a cylinder, you might have seen one face. Being the backside, if you force them, it will not take the shape of a cylinder. It will not take the shape of a cylinder actually. Cylinder means if you allow the water to flow very forcibly, it moves along the surface, and it will not take the deviation at all. I will let you know how with the picture also. When a fluid is forced to flow over a curved surface, such as the backside of a cylinder, the boundary layer may no longer remain attached. Boundary layer, what we told, may not remain attached to the surface and separates from the surface. That process is known as the flow separation. Here, you can see in such a way, you are allowing the fluid to flow from this point left to the right to a great extent. It is flowing, it is flowing, it is flowing. The solid black line is the solid surface, either cylinder or rock or whatever you can call. Okay, fluid is not attaching here. See, the top layer is whitish in color. Okay, moves very straight, and there is a gap of some distance here actually. Okay, that separation is known as the flow separation. We emphasize here that there is an we concentrated here. We have to make an attention here that the no slip condition applies everywhere. There is no doubt. No slip in the sense it is not slipping. It should adhere. Here also it has to adhere. But the thing is that adhere everywhere along the surface, even downstream of the separation point. Even this is the downstream of the separation point. Here also adherence should be there. But since the fluid is allowed to move with certain force, that force makes them to move very straight to a greater extent, or in the path along the force which is applied, rather than taking a deviation along the curve. In previous slide, what happened actually, in previous slide, here as the fluid goes, certainly it should move straight actually. There is no way here, always it should be adhered. If it is being a bent actually, being a bent, even the fluid moves fast. Here you can't get the wetness of that kind actually, wetness of that kind to a great extent. Okay, uh, separation point, a phenomena similar to the no slip condition occurs in heat transfer also. Means don't go with always with the fluid mechanics actually. Transfer of the heat content or the transport of the heat energy, heat from one point to the another point, is also a phenomena which is similar to that of the no slip condition. How means when two bodies are at two different temperatures, there is no doubt. Okay, you can bring them in contact. What happens? Heat transfer occurs such that both bodies have to assume the same temperature at the points of contact. Means to say that the object or the body which is at higher temperature will lose the temperature or transfer the temperature to the body at lower temperature, or the body at lower temperature will receive the energy from the higher temperature, and both will attain the same temperature. Okay, that is the equilibrium temperature. They have to attain the temperature equilibrium. There is no doubt. Therefore, a fluid and a solid surface. Why we are comparing? Because if you are bringing the two objects in contact where the temperature comes to be an equilibrium, if you are bringing the fluid and solid surfaces which have the same temperature at the point of contact here, if they are at the point of contact, this is known as no temperature jump condition. I don't know whether you got it or not actually. Okay, here fluid surface. Therefore, there is a because here there is no, even though no slip condition is there, it will jump. Why it is jump? Because to attain to that extent it will jump actually. No temperature, solid surface have the same temperature at the points of the contact. This phenomena, which phenomena? Fluids which are moving through the curved surfaces will not be in contact with the surface at some point, mainly because they move very straight depending on the force, is known as the no temperature jump condition they can call. Based on this, we can classify the fluids. There is no doubt, because these classifications we want later we will say that only in terms of the terminologies we will proceed. Okay, uh, we defined earlier fluid classes, or maybe in the beginning, fluid mechanics as the science that deals with the behavior of the fluids. How, what kind of a behavior like the temperature, density, or momentum, or even volume, change in the volume, or the pressure. They are the properties. Those properties will change, those behaviors will change, including the shape. Of course, the shape is a different fluid, maybe either at rest or in motion. Okay, even if you are taking a water in a cup and study the properties with reference to the time, how the property will change. Okay, or for example, instead of normal, okay, whichever with the water, if the water as having an energy of about some 60 degree Celsius, and if you allow with the time, how that the temperature decrease meant it can go or adjust with its environment. Or if you allow that the same fluid to move in certain move in certain way, actually, even if it is in motion, like the water which is moving in a lake, sorry, canal, or maybe in pipeline, or maybe somewhere else, and the interaction of the fluids with the solids, particularly in their contact in the closed environment, actually, solids or other fluids maybe at the boundaries, how it has to happen. For example, ocean is having a big huge source of all kind of fluids. The petroleum products, petroleum, kerosene, diesel, everything will be there depending on its density at the bottommost layer of the ocean, and how they are separated, how they are maintained, the intersection in the layer which is in joint between them should have some characteristic feature values, actually, because you can't mix the two kind of an oils, and you can't have a third kind of category or third kind of a product, actually. Okay, depending on the density, they are segregated. Highest density materials will occupy the least position, the lowest density material occupy the highest position of that kind. There is a wide variety of fluid flow problems. Okay, it is not a simple problem of that kind. There is a wide variety in the sense n number of categories are also there. At the same time, varieties are also there, problems which are encountered in practice, but it is usually convenient to classify them on the basis of some common characteristic features to make it feasible to study them in groups. For example, liquids with some known density, liquids with no other density of that kind. If it is the density matches with the density of the water, or the density of the fluid is in such a way that the density of that fluid is greater than that of the water of that kind, as in common thing we can call. There are many ways to classify the fluid problems. Okay, fluid, that is fluid problem senses the flow of the fluids. Particularly problem here, don't think it is a numerical problem of that kind, or maybe the concepts, or maybe how one can understand the phenomena which are going through. Basically, we can classify them into two broad classifications: viscous and inviscid flow. Viscous and non-viscous also they can call. Viscous and inviscid flow of that kind. Here the same thing I'm elaborating, or we will discuss it in detail, actually. Right side, you can see that here, this is the layer between them. The top layer moves with the top. The top layer is the inviscid flow region, and this is the viscous flow between the two region. Okay, a small region which is direct in contact with the fluid to the solid body. Bottom also of the same kind. We'll see the description how it has to happen. You can make use of the same text for your understanding in a better way. When two fluid layers move relative to each other, a friction force develops between them, and the slower layer tries to slow down the faster layer. Simple relation. Okay, assuming that here the fluid is moving from one point to the other point, actually here it is moving. The layer which is moving about two layers, you assume that the top layer is always moving with faster. The lower layer, bottom layer is moving with relatively slower speed. The top layer is try to pull the bottom layer along the direction, but the bottom layer tries to pull the top layer to slow down its speed. Either the way you can call, actually, means because of the high speed, because of this high speed, the top layer tries to grab the material along the direction. For example, if you throw some floating material into a canal, the floating material will also flow along with the water, because that drags actually. But if you allow that to be there with this relatively heavier mass, with this tough material, the flow of water will be dragged by that substance. Here also the same case, but in the case is that what we are taking is the two liquids we have taken. two liquids, in the sense two fluids they can call, or two fluid layers they can call actually, more relative to the each other, a friction force develops between them, and the lower layer always tries to slow down the faster layer. Lower layer try to bring the speed of the top layer relatively down because of the friction. This internal resistance, what it is offering, this internal resistance to the flow of the quantified by the fluid property is known as the viscosity. How much it is gets slowed down is known by a scientific terminology, is known as the viscosity. They define the viscosity. It is a measure of the internal stiffness of the fluid. How much the fluids are sticked between them. Between them. If they are very sticky, they are not moving like a solid. That is, if that is the case, non-viscous they can call. They will never move at all. Okay. If they are not moving, we can't make the property of the fluid for some other applications. Assume that as an iron ore, ferrous oxide, actually Fe2O, iron ore, if it is not taking the shape of it, if it is not having the molten iron of that kind, you can't mold the iron material according to the what desired, like a rods, like a cylinders, like the shape, whatever the container you want. Maybe the cylinders used for the supply of the kitchen gas, home gas, like LPG gas of that kind, or maybe any shape they can call. If materials does not, if material means solid materials does not have the property of a fluidity they can call, they can't be molded into the any required shape. That is one of the major application actually. This internal resistance to the flow is quantified by the fluid property known as the viscosity, which is a measure of internal stickiness of the fluid. Okay, fine. This viscosity is caused by the cohesive force between the molecules in liquids and by molecular collisions in gases. Two things, don't get confusion. Liquid and gases together, they are known as the fluids. That is why explaining sometimes the terminologies will give an example and analogy of both liquids as well as the gases together. Viscosity is a measure of, or which is caused by the cohesive force. Cohesive force is an adhesive force. Cohesive force is an attractive force actually. It bonds and binds the molecules together in liquid. It, because if the cohesive force breaks, then only the molecules will separate each other. You can't expect isolated independent molecules near the surface because of the atmospheric conditions. Okay, and the collisions will happen, and by molecular collisions in gases also will happen because of the cohesive force. There is no fluid with zero viscosity. There is no fluid. Of course, solid will not move. You can't expect the viscosity for the solid. Okay, even being in solid ice, they can call solid water is nothing but the ice. Ice is also having, ice means not the solid ice. Okay, the molecules within the ice should have some viscosity. So they move with some temperature, move with some move between among that actually. Okay, viscosity is caused by the cohesive force between the molecules, and there is no fluid, or there are no fluid they can call, with zero viscosity, and thus all fluids flow involves viscous effects to some degree. Okay, here flows in which the frictional effects are significant are called the viscous flows, there is no doubt. However, in many flows of practical interest, what we are expecting either in laboratory or in the nature, what is happening, there are regions, typically regions not close to the solid surface, where viscous forces are negligible and also small compared to the inertial or pressure forces. The inertial force and pressure forces are also be there. Compared to that, viscous force may be less, that can be ignored. Neglecting the viscous terms in such inviscid fluids, in such inviscid fluid regions, greatly simplifies analysis without much loss of the accuracy for such type of materials. The development of viscous and inviscid regions of flow as a result of inserting a flat plate parallel into a fluid stream of uniform velocity is shown here. This is the parallel plate what they are putting actually. The fluid sticks to the plate on both sides here. It sticks. See that here this is a sticking part of it actually, sticking to the part of it on both sides because of the no slip condition, and the thin layer, bond layer, in which the viscous effects are significant near to the plate. They are not allowing the fluid to pass through actually. It is pulling and trying to hold it actually, hold it. and viscous effect significant near the plate surface is the viscous flow region. The region of the flow on both sides here are always from the plate and the largely unaffected by the presence of the plate is the inviscid flow. Inviscid flow. This here, this the top layer from here, this is inviscid flow. This is inviscid flow actually. Okay, here this between these regions, which was marked as the viscous flow regions, are influenced by the flow. Because of that, can also classify then the fluid into the internal flow and as well as the external flow. Some examples they can go. Of course, it is a beautiful way of explaining the fluid properties. A fluid flow can also be classified as being an internal or an external fluid, depending on whether the fluid flow in a flows in a confined space or over a surface. Okay, confined space means in a controlled manner or maybe in an open space of that kind actually. Okay, the flow of an unbound fluid should not be bound together over a surface such as a plate or maybe in a wire or a pipe is an external flow. Unbound flow means if you allow the water to flow through the canal, okay, it is an unbound flow or surface. Okay, even on a surface of a plate actually, even on a wire means actually if you allow the drop of water to flow in a wire, it flows freely, or even in a pipe is known as an external flow. The flow in a pipe or within the duct, okay, duct is internal flow. If a fluid is bound by the solid surface, means if it is covered by entire thing, means it has to take the shape of the shape of the shape of the container, then only they can say that it is the internal flow of that kind. Water flow in a pipe is internal flow, there is no doubt. And air flow over a ball, for example, on the right side you can see that air is moving through the ball. Otherwise, instead of that, ball is moving in an air is not moving, ball is moving. Ball, if you throw the ball, if you throw the ball actually, the ball has to forcibly move within the air, like almost like a swimming actually. Air you can see that air which is against to that actually flows across the surfaces. It will not take the directions, it will not adhere to the directions on the right side actually. During a windy or over an exposed pipe during a windy day is an external force. The flow of liquids in a duct is called the open channel, like a canal they can call flow. If the duct is only partially filled with the liquid and there is a free surface. Free surface means maybe even though it is completely filled also it is a duct they can call, but the top surface should not be closed one. The flow of water in rivers and irrigation ditches are examples of such open flows. Internal flows are dominated by the influence of the viscous throughout the flow fluid. In an external flows, the viscous effects are limited, particularly to the boundary layers near the solid surface and to wake regions and the downstream bodies. Being this, can also classify them as the compressible and as an incompressible fluid. Compressibility comes means how can we compress the fluid? There is no doubt if you take an atta like a wheat, if you take an atta like a maize, if you take an atta like an something like that, if you press it, you can put it. Means the same volume, you can put more and more by the way of the compression. Let us imagine in 1 liter of bottle, put in 1 liter water, try to press it. No, you can't put 110 ml, sorry, 1010 ml. You can't even add 10 ml also extra to that water bottle actually. If it is exactly filled by 1 liter, there is no doubt wherever you go that should be the 1 liter. Of course, it is also a function of the temperature and the pressure of the atmosphere, that depends. A flow is classified as being compressible or incompressible. Don't split the word in and compressible. Okay, they are incompressible is not compressible, depending on the level of variation of density during the flow. Okay, incompressibility is an approximation, there is no doubt, in which the flow is said to be incompressible if the density remains nearly constant throughout. Okay, if the density changes, for example, by some means, if you are pressurizing, if you are compressing, means certainly density has to go up. If the density goes up, those fluids are called the compressible fluids. Remains constant for the liquids. Therefore, the volume of every portion of a fluid, if it is in movement, remains unchanged over the course of its motion when the flow is approximated as an incompressible. Densities of liquids are constant, there is no doubt, and thus flow of liquids is typically incompressible. Therefore, while handling the problems, we can say that either for the compressible fluids or incompressible fluids, all liquids are taken as for practical applications as an incompressible fluid. Therefore, liquids are usually referred to as an incompressible substances. For example, even if you allow the pressure of about a 210 atmospheric pressure to 10, means atmospheric pressure is about 1000 hectopascal or 1000 millibar, what you're expecting, if you're raising the pressure to about 200 times more than that, causes the density of the liquid water at 1 atmosphere to change by just 1%. Even if you're increasing the atmospheric pressure 200 times more, it may change in the pressure for liquid water by 1%. It is not much appreciable. That is the intention. Instead of the liquid water, if you apply it for the gases, including maybe the water vapor, they are highly compressible. Even a change in the pressure just by 0.01 atmospheric pressure, assume that 900 hectopascal is the pressure over Bangalore. If the pressure drops by about 0.01 1 atmosphere, causes a change in 1% in the density of the atmospheric air. Density means if it gets rarefied, the density will come down, and if it gets compressed, density will increase. Let us assume that from the sunrise, time of occurrence of the sunrise around 6 o'clock, 6:30 right now, okay, because of the absorption of the energy, molecules will gain energy and expand and will move aloft to the upper atmosphere, thereby reducing the pressure near to the surface. At the same time, it also reduces the density. Don't get confusion. Reducing in density in the sense number of molecules per unit volume. The density of air will not change. The pressure of the air will not change to a great extent. Why the density? We are saying that, of course, in general, the layer will move up and tropopause layer will move up and tropopause layer will come down actually. Thereby changing that height of the layer, the density and pressure will change. Density of the air for a given temperature and for a given temperature, it is having the same density. For a given pressure, it is having some density of that kind. Change. When analyzing rockets, for example, why we want this mainly because when we are analyzing the rockets, means rockets or spacecrafts or any other kind of systems which involves with high speed fuel is gets converted into energy. Fuel burns up and the energy gets converted into the fuel energy to some energy of that kind. When it is allow when it flows through the what we can call the nozzle of an engine, actually the fluid is allowed with huge pressure or high pressure of that kind. Actually, because of that high pressure, the properties will change. Okay, it involves with high speed gas flows. The flow speed is often expressed in terms of some dimensionless number they can call Mach number. Mach number they can call, instead of Mach, you can call Mach. Mach number, Mach number, which can be defined as the M suffix A, don't put as an MA times, should be speed of the flow to the speed of the sound. Speed of the flow of a fluid to the speed of the sound. Okay, where C is the speed of the sound, don't go for the C as the speed of the light actually. Okay, the ratio of speed of the flow of the fluid to the speed of the sound, what you are expecting, that number, that is the dimensionless quantity, that number, that index gives as the Mach number. For example, value of 346 meter per second in air at room temperature at sea level, okay, for atmospheric air actually. A flow is called the sonic when the number is exactly equal to 1. Okay, speed of about 330 meter per second to 340 meter per second, what you're expecting the speed of the sound actually. If it is less than that, you can call subsonic. If it is more than 1, you can call it as a supersonic. If it is too much greater than 1, you can call it as a hypersonic. That is how that classification will be there. They can compare the flow of the fluid and with the flow of, that is the speed of the flow of the fluid, with the speed of the flow of the sound. If it is less than the speed of the sound, is the subsonic. If it is equal to the speed, sonic. If it is greater than that, it is called the supersonic. If it is still greater than, too much greater than the speed, is called the hypersonic of that kind. Thereby getting two kinds of flows: laminar flow versus the turbulent flow they can call. What do you mean by laminar flow? Laminar should be in the same line, same thing which is going ahead of it actually. Okay. Uh, Some flows are smooth and orderly, while others are rather chaotic. Some flows are very smooth and they are moving in perfect direction. Means all flows should be laminar. You are using the pens for writing either from gel or maybe non-gel or maybe a solid ink, okay, where the fluid, particularly ink, in a refill has to move very smoothly. That is why the flow should be very laminar flow. It should be linear flow. Okay, it should not be turbulent. It should not be like an the water which is while during boiling will move in the other direction. Okay, it should not have that kind. It is not chaotic also. The highly ordered fluid motions are characterized by the smooth layer of the fluid is called the laminar flow. The word laminar comes directly from the movement of an adjacent fluid particles. Together they are calling it as the laminae. The flow of high viscosity fluids such as oils are having more viscosity at low velocities is typically laminar. If you increase the speed, the temperature, sorry, if you increase the speed by some means, they becomes the turbulent. The highly disordered flow of the motion of the fluid typically occurs at high velocities and is characterized by the velocity fluctuations. They can call change in the velocity or change in the speed of the fluid along the direction of the flow of the fluid. That's why we are calling it as a velocity. Is called the turbulent. Atmosphere is turbulent. People can say that when you are traveling in air through aircraft, sometimes pilots will say that we are entering into a cloud where that cloud is more turbulent. Where they can't call it as a cloud. Then we are entering into a turbulent air. If it is a turbulent air, it is very difficult for the aircraft to pass through. Certainly, it gets vibrations. Sometimes it may not. If it is too high, it may uplift also. It may be thrown out in the sense it can move in a random direction, or it may not be under the control of the pilot. Usually pilots will never take the aircrafts within the clouds which is having a turbulent. Okay, normally they will take deviations. Okay, by some means for small clouds sometimes they enter or sometimes they can't be avoided also. Assume that a cloud of about 100 and 200 kilometer wide, if it exists there is no chance for them to move, they have to pass through for a few minutes. Okay, the flow of viscosity fluids such as air at high velocities is typically turbulent, there is no doubt. A flow that alternates between the being laminar flow and being turbulent is known as the transitional. The top layer is the laminar. Maybe if it is visible, visibility is not can be seen mainly because of the dust and other particles. You can see that fluid is moving from left to right or right to left. We don't know. Certainly linear flow. The bottom layer is highly turbulent. You can see the shape of a clouds of that kind actually. Okay, either even such type of things will you can observe preferably in gases rather than liquids to a great extent. And here is the transitional. Even in liquids also, if you are allowing the water to flow in a canal, if there are huge rocks which are coming, the water will not move laminar linear, it will get turbulent actually, that kind, like including swirling. There is also classification, maybe this last slide actually. Natural versus the forced flow of that kind. Natural one is called the unforced flow. Other one is called the inevitably the forced flow of that kind. A fluid flow is said to be natural or forced depending on how the fluid motion is initiated. In forced flow, a fluid is forced to flow over a surface or in a pipe of that kind, you can expect it of that kind of. In natural flows, fluid motion is due to natural means such as the buoyancy force, buoyancy effect they can call, which manifests itself as the rise of warmer or maybe the lighter two together. Warm air rises up, cold air sinks down. Cold air becomes cooler, air becomes denser and sinks down. Sinks, need not be down. Okay, and warm air because of the lighter, it has to move up. The right side, whatever you are seeing, the picture is being a human being. Okay, while having an exposure to the bath, you can see that hot air which is touching that rising upward. Okay, and from the back side, bone side, okay, you can see that it is sinking of the cold steam. Steam may be the same temperature. Here right side is right side picture is the hot, the left side should be the cooler of that kind. In solar hot water system, what we are expecting, and the thermo siphoning what we are expecting effect is commonly used to replace the pumps by placing the water tank which can sufficiently above the solar collectors. Solar collectors where you are having, where the hot water moves upward, the cold water comes down, and there maybe the circulation will happen actually, because that you can see if you are having a solar panel, go on top to the terrace and see that if it is a transparent material they are made of course it should be transparent. Even the mechanism, if that is a transparent actually, the hot rises up, cold goes down and makes the circulations. Otherwise, take a beaker of water, okay, increase the temperature by some means, keeping it on a stove or something like that. Water molecules will move upward. They are the lesser in temperature, sorry, higher in temperature will move upward. The cooler molecules will come down and makes the circulation to a great extent. By this means, we'll come to the classification of the liquid again by the steady flow or maybe unsteady flow. Two diagrams you are seeing that both are the same thing. It is they are the photography taken for a water which is falling down from the top. There is no doubt water has to fall from higher potential to the lower potential. The terms steady and the uniform are frequently used in engineering, in science and scientific fields, and it is of importance to have a clear understanding of their meanings, whether the steady flow or maybe an unsteady flow of that kind. Steady and uniform may be put together. Unsteady and disturbed or chaotic they can put together. The term steady implies there is no change of properties. Steady flow means no change of the properties in the sense no change in the velocity, no change in the temperature, no change in the direction. Of course, direction may change. Of course, no change in the speed of the moment of the flow of the speed of the movement of an fluid actually at a point with respect to the time. But the opposite to the steady, you can call it as an unsteady in terms of the grammar literature. The term uniform implies to the no change. Uniform means no change is called the uniform. If there are changes, it is called the non-uniform with the location over a specified region. These meanings are consistent with their everyday use, there is no doubt. The terms unsteady and transient we can call, transient also called between the stable to the unstable is called the transient, are often used interchangeably, but these terms are not synonyms. Unsteady and transient are not the synonyms of that kind, but we can use to that extent. What happens here in the right side, you can see that in fluid mechanics particularly, unsteady is the most general term that applies to the any flow that is not moving with steady speed, with constant speed. But transient is typically used for developing the flows. If the flows are developing in called transient feeds. The left and right diagrams are the one. Left side is one snapshot of a photography where water is falling. The second one, the same thing, if you expose it for a longer duration, it looks like a continuous picture, continuous falling. I don't know whether you are aware of it. While taking the photography, if you increase these snapshots for a given second, cluttering, simply go on keeping 10 photos, 30 photos, 100 photos. You see that even a person which is moving will move continuously. It is a continuum. It is not a discrete. Left one you can see the discrete. Okay. The right one you can see the continuity. Flow of the fluid is continuous. Continuous. There is no doubt you can see that. Even while taking movies earlier, they used to have a camera with the exposed with the films. If they move the what they can call films almost 10 films per second, 10 films per second actually, 1/10 of a second they can call. Okay, that can make it as the continuous moment. Otherwise it becomes discrete, that can be taken as, if you bring the 10 pictures together within 1 second, then that becomes a continuous in fluid. Okay, what here is there, this is the difference between the two diagrams. Okay, uh, when the rocket engine is fired, there is no doubt there are transient effects which are happening. Particularly what type of a transient effects? The pressure builds up inside the rocket engine. That flow accelerates the engine until the engine settles down and operates steadily. There is no doubt. The term periodic also refers, periodic means occurrence of the same phenomena for a no periodicity, to the kind of unsteady flow in which the flow oscillates about a steady mean. Many devices such as turbines, wherever, compressors, boilers, condensers, and heat exchangers operate for long period of time under the same conditions, and they are classified as steady flow devices. But During the steady flow or uniform flow, the fluid property can change from point to the point with a device, but at any fixed point, they remain constant. Okay. Therefore, either the volume or the mass or the total energy of the content of a steady flow device or maybe the flow section remains constant in steady operation. That analogy is shown in the figure. It may vary from point to point. For a given point, that is the known mass of the fluid, known speed of the fluid, known density of the fluid, that should remain constant. This is the difference between the steady and unsteady flow. They are the some of the classifications. Okay. Next class we will go ahead with this some more important features of the important features of the important features of the fluids. Actually, we'll take it up in next class. Thank you. Thank you anyway. I'm very happy to address any of the queries or questions or doubts, or even, of course, appreciation is not required. I'll take it up. Thank you, Ananda. I'll stop sharing the screen. If you are having a query, I will attempt it. There are no queries. I will stop the class. I wish you all the best. Is it okay? Naresh Babu, Anuradha Sharma, Pallavi, shall we wind the class?
Okay.
Okay, sure. Thank you.